Hello, this is our career video on biomedical engineering. So there are many great universities out there that provide excellent programs in biomedical engineering, each with their own unique advantages. Some of the more notable universities with great biomedical engineering programs are MIT, or the Massachusetts Institute of Technology, Rice University, Carnegie Mellon University, Arizona State University, CIT, and UC Berkeley, including many, many more. Some of the degrees that would be useful to your career as a biomedical engineer are a bachelor's or master's degree in bioengineering, or a bachelor's or master's degree in biomedical engineering. And here are some useful certifications that would be helpful in your career as a biomedical engineer. Some of the more useful ones are CCE, or Certification in Clinical Engineering, CBET, or Certified Biomedical Equipment Technician, CLES, or Certified Laboratory Equipment Specialist, CETMA, which is Master Certified Electronics Technician, and CBA, which is Certified Biomedical Auditor. There are many, many more certifications out there. A lot of them are very specialized depending on what field of work you want to go into, but these are some of the more general, useful certifications that would be helpful for you. And all of those certifications will only help better prepare you to be a better engineer, and will build up your resume in the process. So, one timeline for a student to get a jump start on a degree starts with scouting out universities that offer biomedical or engineering or something similar as a degree, and deciding using numerous factors, whether it be cost, location, accreditation, etc., which university is the best choice. Next, decide which degree to pursue, which we talked about earlier, and which other certificates, which we also talked about earlier, would be best to augment your chosen degree and ultimately your career in the long run. During university, familiarize yourself with different firms in the biomedical engineering industry. Some of these include Amgen, and Johnson & Johnson and Phillips, and look into any internship or co-op opportunities that they might provide, and how each company's offerings suit you, your needs, and your goals. Look to begin your first internship or co-op after your sophomore year to give yourself the most exposure in the industry, and also to find a potential landing spot for after you graduate. Another great option is co-op, which both covers your studies and your work experience at the same time. And then lastly, graduate. That's the last step. And there are lots of great internships and co-op programs out there, they're an amazing way to build up your knowledge and skill set before fully entering into your career. There are internships on offer, such as a biomechanics intern, clinical engineering intern, and intern for oral healthcare research and development.
In biomedical engineering.
Biomedical engineering, a solid technique for preparing for one's future, is to investigate and research in depth all of the many different fields in biomedical engineering one can get into. For example, if one wants to focus more on the neurological side of biomedical engineering, neural engineering might be the way to go. Neural engineers create neuroprosthetics, which are devices that enable persons with motor or sensory problems to recover control of their senses and motions by connecting the brain to a computer. They also develop deep brain stimulation technologies to cure neurological illnesses and advance in neuroscientific research. On the other hand, one can focus more on materials or electronics in the biomedical engineering field. Engineers that work in biomaterials concentrate on creating materials that were safe for humans to use. They make medical or dental implants and medication delivery systems. Biomaterial engineers investigate and create novel materials, evaluate their biocompatibility, and examine how they interact with live tissues. They also develop biomaterial scaffolds, cell culture methods, and growth agents to stimulate tissue regeneration. They want to create modified tissues for transplantation, drug testing, and regenerative medicine applications. There are also pharmaceutical engineers who use engineering and pharmaceutical science to create medication delivery systems and production procedures. They design and optimize medication formulas, create controlled release devices, and endeavor to prove drug stability and bioavailability. One other type on biomedical engineers are system psychology engineers. They use engineering ideas and psychological expertise to comprehend and stimulate complex biological systems. These engineers investigate and increase our understanding of human psychology by analyzing psychological data, developing computer models of psychological process, and using system engineering methodologies. After one has made their own personal degree specialization or broad choice, the next best step is to look for well-structured internship programs before classes start. This aids in career planning and frees up time to concentrate on education or other activities. Setting realistic objectives is critical to academic and professional success. These can be as simple as getting A's in your classes, or as big as setting aside enough money to pay for your next semester in full. Creating a solid basis for semester goal setting through one's undergraduate years enables for rapid and easy goal setting later in one's career. Time management skills are also required for academic and professional success. Without proper time management skills, activities and projects become more difficult, and more time is spent considering how to do them. The ability to manage time properly is invaluable during times of project overload, allowing the completion in a fair amount of time. By setting the groundwork in college with structure and assistance, one's career will become less stressful and more efficient. Overall, a well-prepared engineering profession may be both gratifying and rewarding. Engineers examine conditions, identify problems, and create solutions. Planning is a crucial skill to have when working as an engineer. One has to plan their schedule so projects and tasks that were given can be completed on time. Organization is also very important, so no one feels overwhelmed or confused about what is happening or where things are at. Programmabilities are required in a variety of technological sectors, and candidates must be dependable under pressure. Because of how much pressure or work projects can have, few engineering projects will have an engineer working alone, without teammates or outside specialists. Teamwork is essential for maximizing potential and ensuring technological plans are accurate. Being accurate is very important in engineering. It requires meticulous attention to detail, and as little errors can result in significant financial losses or someone getting injured. An error in engineering can be caused by something as simple as miscommunication. Effective communication is crucial for success, since engineers frequently work in groups, get feedback from others, and sell their projects to clients. Good communication also helps with risk management, since engineers must be able to clearly and efficiently address possible risks, such as monetary, safety, and timetable problems. These abilities.
What is biomedical engineering? Biomedical engineering is the use of engineering to solve biological and medical problems in order to improve healthcare. There are a lot of tools and equipment that go into this job. Small medical tools such as a stethoscope or scalpel, and also big machines such as an X-ray or MRI. Biomedical engineers have also designed and continue to work on artificial pieces of the human body, Pieces like artificial hearts, prosthetic limbs, or any other kind of piece that holds bones or ligaments together. There are a lot of career opportunities with this job, some being clinical engineering, research engineering, bioprocess engineering, and project management. First is clinical engineering. Clinical engineers are very important to the medical world because they're constantly finding new ways to help patients and doctors. Clinical engineers also typically focus on building, designing, and testing products. Many of these products are going into patients, which means testing is very important. Next is research engineer. Research engineers play a big role in providing quality information to any other engineer who needs it. The first step of the job is to collect data. Next is to analyze that information. And lastly, they must interpret the results to give it to whoever needs it. Next is bioprocess engineer. Bioprocess engineers build equipment to help study living organisms such as cells. An example of this could be a microscope. This is very important to the medical field though, because it can relate to patients that are seeking skin grafts. It's also important for making sure new medical devices are suitable for the human body. Lastly is the project manager. This role is found in pretty much every engineering discipline. Project managers oversee jobs to make sure it runs smoothly, has an accurate timeline, and the expenses get recorded to make sure the job doesn't go over budget. Project managers play the same role across the board, but they still have their own specialties for each discipline. Some societies in biomedical engineering is the BMES, Biomedical Engineering Society, and AIMBE, American Institute of Medical and Biological Engineers.